Good morning, students. Hope you are all well and healthy. Today I will start my condensed matter physics unit 1. In this unit, today I will teach about vibrations of monoatomic atom in a one-dimensional lattice. Monoatomic means we are all know there is only one atom, and what will be the vibration when it is presented in a one-dimensional lattice. In earlier solid state physics, we might study about lattice. There is one-dimensional lattice, two-dimensional lattice, three-dimensional lattice, etc. Here it is one-dimensional lattice. What do you mean by a lattice? Lattice is nothing but there are number of points in a particular space. The points are arranged in a regular manner, and that points are called as lattice points, and that plane is called the lattice. So now if one atom is presented in a one-dimensional lattice, what will be its vibration? So in this class, when it vibrates, we should calculate, or we want to calculate, or we are going to calculate the angular frequency omega. Okay. Now a wave propagates through a lattice. Consider a wave is propagating through a lattice. When a wave is propagating or displacement takes place, then there will be vibrations, and these vibrations are represented by wave vectors. Wave vectors are generally represented by the letter K. You should all know in solid state physics, wave vector is represented by the letter small k. That value should be equal to 2 pi by lambda. We are all know. Now each wave vector consists of three modes. When it vibrates, when we are representing by wave vector, it consists of three modes. One is the longitudinal mode along the x-axis, and two transverse modes along the y-axis and the z-axis. Okay. So each vector consists of three modes. One should be along the x-axis and it should be longitudinal mode. Y and z-axis consists of transverse mode. We are all aware about longitudinal vibration and transverse vibration. What is longitudinal vibration? When the propagation of a wave and the plane are perpendicular to each other, then that vibration is called as longitudinal vibration. Clear? When a wave is propagates in a plane, the vibration of the medium and the vibration of the wave both are perpendicular to each other, then that type of vibrations are called as longitudinal vibrations. Propagation of the wave, vibration of the medium are parallel to each other, then it is called transverse mode. So here, when a wave propagates through a one-dimensional lattice, three modes will be arised. One is the longitudinal vibration and it should be along the x direction. Other two modes will be arised. They are all transverse modes and it should be along y and z axis. Okay, right. Now we vibrate. When an atom vibrates, there will be changes taking place in its amplitude. If there is n atom, the amplitude of nth atom will be xn. It should be along the x-axis. xn plus 1 and xn minus 1 are the amplitudes of vibrations of n plus 1th and n minus 1th atoms on either side of xn. Consider xn will be at the center. At one side it should be xn plus 1, and other adjacent other side it is xn minus 1 atom is there. In the next slide I will show the image, then you should be clearly understand the things. Now it is assumed that atom is a very small one. The vibration of the atom is very small, so the amplitude of vibration is also small. So this is maintained by the force acting between them, and it should be governed by Hooke's law. Do you understand? When atom is small, the amplitude is also small, and it should be maintained by the force between the atoms, and it should be governed by Hooke's law. We are all aware about Hooke's law. Stress by strain equal to constant. That is, stress is directly proportional to strain. So this is Hooke's law. Okay, right. Now this is the diagram. When the atoms are in the equilibrium position, this is n, these are n plus 1, n plus 2 atoms, and these are n minus 1, n minus 2 atoms. So there is the atom, and n plus 1, n plus 2, n minus 1, n minus 2 are on either sides. Okay, right. So this is the x direction, this is A is the amplitude change. Now when there is the displacement takes place in every atom due to the vibration, this is the nth atom position. When it vibrates, it going to this direction. This is n plus 1th atom position. When vibrates, it move to this position. This is n plus 2 position. When it vibrates, in this direction. Similarly for n minus 1, n minus 2, etc. This distance between these two called xn. The distance between these two are called xn plus 1. The distance between these two are called x of n plus 2. Similarly on this side, this is xn minus 1. This is xn minus 2. Are you understand now? This is xn. This is xn plus 1 in this direction, and this is xn minus 1 in the opposite direction. Okay, amplitude are same but direction is different, that's all. Okay, now when this vibrates, what will be the equation? That is, when force of the nth atom due to the interaction with the nearest neighbor is given by m dx square n by dt square, which is nothing but acceleration. Okay, ma equal to minus fx. This is the formula. When a vibration of the when there is the vibration takes place, the atom, what is its value? Ma, that is equal to f into x. Okay, minus fx, it is the general formula. So m into or minus kx, in some books it will be minus kx. Okay, so m d square xn divided by dt square, that is equal to minus f xn minus xn minus 1 minus f xn minus xn plus 1. Do you understand? This is for one direction and this is for another direction. M is the mass of the atom and F is the force constant. In some books it will be represented by K. Okay, right. Now when you simplify it, m d square xn by dt square, that is equal to, if here one xn is there, minus xn, and here or minus xn, therefore it is minus 2xn. Then minus of minus plus xn minus 1 minus of minus plus xn plus 1. So f of xn minus 1 plus xn plus 1 minus 2xn. Are you understand this equation? Okay. So if it is the second order equation, what will be its periodic solution to the above equation is xn, that is the amplitude. Xn is equal to a e power I omega t minus kna. We know this equation, a e power I omega t minus kna, where k is the, here you see, wave vector. K is the wave vector, n is the atom, a is the distance between the atom, t is the time of propagation. It should be is equal to 2 pi by lambda square into sine theta. Okay, xn is equal to, this is the main equation, xn is equal to a e power I omega t minus kna. Okay, when this amplitude change takes place, it represents a sinusoidal disturbance with angular frequency omega and wavelength lambda. Now, that equation for xn, so for n plus 1 and n minus 1, there are, you see, xn plus 1, that is equal to a e power I omega t minus k. In that equation it is kna because it is a nth atom. Here it is n plus 1th atom, therefore instead of n, it is n plus 1 a. xn minus 1, that is equal to a e power I omega t minus k n minus 1 into a. I think it is very easy for you. The basic equation is xn is equal to a e power I omega t minus kna. For nth atom it is kna, for n minus 1th atom it is kn minus 1, for n plus 1th atom it is kn plus 1 into a. Okay, so it is equation 3. Now differentiate the equation 2 twice with respect to time. What is the difference? What is the second equation? xn, that is equal to a e power I omega t minus kna. First you differentiate dxn by dt, that is equal to a is the constant, therefore a e power something into something derivative. It is the general differential formula. So a e power I omega t minus kna into I omega. Are you understand? Into I omega. Then differentiate again. So d square xn by dt square, again it will come I omega a e power I omega t minus kna into again 1 I omega. Therefore I square omega square a e power I omega t minus kna is the final result. I square is nothing but minus 1. Therefore this equation is d square xn by dt square, that is equal to minus omega square a e power I omega t minus kna. Do you understand how it comes? That is xn, that is equal to a e power I omega t minus kna. When you differentiate it, a e power I omega t minus kna, it will come as it is, then into I omega, because with respect to t we are differentiating, so this is constant, it will become 0, therefore I omega. Again differentiating, again 1 I omega will come, therefore I square omega square a e power I omega t minus kna. Okay, understand? Okay. Now, so take this value that is d square x and y dt square value in the first equation and add the equation 3. Add the equation 3. So now minus m omega square ae I omega t minus kna, that is equal to f of ae power I omega t minus kn minus 1a plus ae I omega t minus kn plus 1 into a minus 2ae I omega t minus kna. Then you take this ae I omega here. So minus m omega square equal to this thing. Then you divide each term, that is ae I omega t minus kn minus 1 into a divided by ae power I omega t minus kna plus ae power I omega t minus k into n plus 1a divided by ae power I omega t minus kna minus 2ae I omega t minus kna divided by ae I omega t minus kna. So they cancel I, where it becomes 2 and the remaining term will be e power minus ika. For this term it is e power ika. You just do it in the home and you follow my notes. I think all will download my notes and you follow it. It will be very easy. If you have any doubt, then I will clarify it. Okay, right. So it is very simple mathematical calculation only. So minus m omega square, that will be equal to 2f e ika plus e minus ika divided by 2 minus 1. Now for that solution, minus m omega square is equal to 2f cos ka minus 1, or it is this minus, when you are changing 1 minus cos ka, here 1 minus, here 1 minus will come, it both will cancel. So m omega square, that is equal to 2f 1 minus cos ka. So 2f, the 1 minus cos ka is nothing but 2 sin square theta by 2. Therefore sin square, instead of theta it is ka by 2, or omega square, that is equal to 4f by m, 4f by m sin square ka, or omega equal to, take the root of 4f by m sin ka by 2. Right. Now this sin ka by 2 have a maximum value of plus 1. If it is sin ka by 2 is maximum, then its value should be plus 1. Then omega maximum, that should be equal to 4f by m. Okay, omega maximum is equal to 4f by m. So instead of 4f by m, you substitute omega max. So omega is equal to omega max sin ka by 2. So this is the main equation we want to calculate. Omega is equal to omega max sin ka by 2. So this is the angular frequency when there is an atom in a one-dimensional lattice when it vibrates. Okay, omega is equal to omega max sin ka divided by 2. Now when you draw a graph, this is 0 position. When you are getting a maximum, it is pi by a. When it is a minimum, then it is 2 pi by a. This is 3 pi by a, 4 pi by a, like that. Here it is in the opposite direction, minus pi by a. Only amplitude are same, only direction is changing, values are same. You see, it is pi by a, it is minus pi by a. So it is minus pi by a, minus 2 pi by a, minus 3 pi by a, minus 4 pi by a, like that. Right. Here this is first wave factor k1. This is in the positive side k1. This is k2 and this is minus k2. This is k3 and this is minus k3. Only it is represented, each atom is represented by a wave vector. Both are in this direction. One in the right side, another one is in the left side. Okay. This equation, this graph is called as dispersion graph, and this relation is called as dispersive relation. Why it is dispersive? Since omega is not a linear function of k, the medium is dispersive. So this is the rule. When omega is not a linear function of k, it is not a linear function of k, it is an exponential function. So when omega is not a linear function of k, the medium should be a dispersive medium. Hence, it is called as dispersive relation, and the graphical representation is as shown in the above. Here, there will be two types of symmetry will be takes place. Two types of symmetry. One is translational symmetry, another one is mirror symmetry. One is the translational symmetry, another one is the mirror symmetry. Here in the translational symmetry, the value of k should be between minus pi by a to plus pi by a. Minus pi by a to plus pi by a. Hence it is called as first Boolean zone. First Boolean zone means the range k should be minus pi by a to plus pi by a. You should remember this word and this equation and this word first Boolean zone. Second Boolean zone will be minus 2 pi by a to plus 2 pi by a, like that. So the extreme value should be k maximum is equal to plus or minus pi by a. Maximum value should be plus or minus pi by a. So this is the translational symmetry value. In the mirror symmetry, what it happens, in addition to the translational symmetry, the dispersion curve has a mirror symmetry about the region in k is equal to 0 in the k space. That is omega minus k is equal to omega of plus k. What is the difference? Where the mode k with k greater than 0 represents a wave traveling through a lattice in the positive direction, and minus k represents the wave moves in the negative direction. Therefore, there are two mirror symmetry takes place, one along the positive direction, another along the negative direction. So, this is the symmetry in k space in the first Boolean zone. So this is the derivation for the vibration takes place when it is a monoatomic atom in the one-dimensional space. Okay, right. So what we saw, when a monoatomic atom, that is when one atom is vibrate in a one-dimensional lattice, we should calculate the angular frequency omega, and that angular omega is equal to omega max into sine ka by 2. It is the main equation. From that we should find out the symmetry. There is two symmetries. One is the translational symmetry, another one is the mirror symmetry. For a translational symmetry, it will takes place minus pi by a to plus pi by a. This range is called as first Boolean zone. Then for the mirror symmetry, one will be along the positive direction, another one will be along the negative direction, but the amplitudes are same, wave vectors are same. Okay, so this is vibrations of a monoatomic atom in the one-dimensional space. If you have any doubt, please ask me in WhatsApp or in the Google Classroom. I will post this in a Google Classroom. If you have any doubts, you please clarify it. You ask me in WhatsApp or in Google Classroom. Okay. In the next class, I will teach you another topic. Okay. Have a nice day. Be safe. We will meet in the next class. Okay. Thank you.